All right, welcome to the Explainer. Today, we're going to dive into a hidden force that powers pretty much every major machine you can think of, from a farm to an airport runway. And no, it's not electricity, and it's definitely not magic. It's the incredible, unseen power of oil hydraulics. I mean, have you ever really stopped and just watched a giant excavator at a construction site? You see its massive arm scoop up literal tons of earth, and it just seems so smooth, almost effortless. What kind of power is going on inside that thing? How is that even possible? While the answer might actually surprise you, we live in an electrical world, for sure. But the heaviest lifting, the real grunt work, that isn't done by motors and wires alone. Nope, it's done with pressurized fluid. And to get how that works, we first need to see where it's been hiding, right in front of us all alone. So let's kick things off with part 1, the world's strongest machines. We're going to take a look at where this hidden force is powering some of the most impressive machinery all around us. You see, oil hydraulics is what experts call a foundational technology. And what that really means is that it isn't just for one specific industry. It's a fundamental tool that cuts across dozens of fields. It's the muscle that lifts the arm of that excavator, yeah, but it's also the power running a massive combine harvester. It's a critical system that moves the landing gear on an airplane, and it's the immense force behind the giant presses in a factory. Seriously, it is everywhere. Okay, so how does it all actually work? You might think this is some high-tech, modern invention, but the core principle? Oh, it's ancient, it's elegant, and it's surprisingly simple. It's an idea that's actually older than Rome. The science behind it all is called hydrostatics, and the key idea is, well, it's shockingly simple. When you put pressure on a fluid in the sealed container, that pressure spreads out equally in every single direction at once. So the real magic here isn't about fluid in motion. It's about the incredible power of a fluid that's just sitting still under pressure. And this right here, this is the magic trick at the heart of all hydraulics. It all boils down to a simple concept. A small push on a small area creates a big push on a big area. So if you apply just a little bit of force to a small piston, you generate pressure in the fluid. But that exact same pressure, when it acts on a much, much larger piston on the other side, creates a massively bigger force. It's a fundamental way to multiply force, using nothing but liquid. And get this. This idea has been kicking around for an incredibly long time. We're talking about the ancient Greeks, guys like Ctesibius, who were already messing around with water pumps. Flash forward over 1,500 years, and you've got Renaissance inventors sketching out designs that look pretty familiar. Even Johannes Kepler, yep, the astronomer, the planet sky, he got in on the action. But the real revolution, the one that gave us the machines we have today, didn't happen until after World War II, when oil replaced water and everything changed. And Kepler's contribution was a huge conceptual leap. He realized his gear pump could create a continuous flow of fluid where, in his own words, no valves are needed. Now that might sound like a small detail, but simplifying the design like that was a key step toward the powerful, efficient systems we rely on 400 years later. Okay, so we've got the history, and we've got the principle of multiplying force. But how does all of that come together inside the unseen power system of a modern machine? Let's take a look. When you break it down, any hydraulic circuit is basically a closed loop that does 3 main jobs. First, you have the pump. And believe it or not, its main job isn't to create pressure. It's to create the flow of the fluid. Next, you have valves, which act like traffic cops, telling that flow where to go and controlling the system's pressure. And finally, you have something like a cylinder, which takes all that controlled flow and turns it into a powerful straight-line push or pull. And what's really cool is no matter how ridiculously complex the machine is, it's always built from these same key players. You can kind of think of it like a body, right? You've got the fluid, which is like the blood. The reservoir is the tank that holds it all. The pump is the heart of the system, creating that constant circulation. The valves are the brains, making all the decisions. The actuator, that's the muscle, doing the heavy lifting. And of course, you've got the lines, the pipes and hoses that connect the whole thing. I know this can all sound a little abstract, so here is a fantastic analogy to make it all click. A hydraulic system is a lot like an electrical circuit. Hydraulic pressure is like voltage. It's the potential, the force waiting to be used. The flow rate of the fluid is just like electrical current. It's the energy actually moving through the system. And the pipes and hoses, well, those are just your wires. So you might be asking yourself, okay, if we've got electricity, why bother with all this messy fluid and pumps and stuff? Well, that is a great question. And the answer is that, like any technology, hydraulics comes with a very specific set of pros and cons. The number one advantage, the absolute killer app for hydraulics, is something called power density. That's just a fancy way of saying you get a ridiculous amount of power out of a really small, lightweight package. It's also great for creating simple, powerful linear forces, pushing and pulling. But on the flip side, it's not as efficient as a direct gear-to-gear drive, and the whole system is super sensitive. A tiny bit of dirt in the fluid can cause huge problems, and all those high-precision parts can get pretty expensive. So with those trade-offs in mind, where does this tech actually make the most sense? This chart tells the whole story. Remember that power density thing we just talked about? Big power, small package? Well, that is why almost half of all hydraulic systems are in mobile machines. All those excavators, tractors, and loaders where you need the most power possible in a very limited space. That's where hydraulics just can't be beat. All right, for our last section, let's talk about the future. Because you might think this is old school tech, but trust me, it is not going anywhere. It's just getting smarter, greener, and a whole lot more connected. The future of hydraulics is all about fusing it with modern electronics, a field called mechatronics. As part of the whole Industry 4.0 movement, smart sensors and computer controls are making hydraulic systems more precise and efficient than ever before, and there's a huge focus now on energy recuperation. That means capturing and reusing energy that would otherwise be lost, like when you lower a heavy load. It's making the next generation of machines way, way more efficient. You know, when you really think about it, hydraulics is the perfect example of a powerful, essential technology that just works tirelessly behind the scenes. It's a great reminder that often the most important forces shaping our world are the ones we don't even see. So the question is, what other hidden forces are out there just waiting to be explained?